I am Dr. Mahua, an MBBS graduate from this institution, batch 2017 to 23, and currently I am a non-academic GR in Department of Obs Gynae at LDBH. I'll be presenting on the topic of etio-pathogenesis of type 1 diabetes mellitus. So type 1 diabetes mellitus, it is also known as the insulin-dependent diabetes mellitus, and it results from an autoimmune destruction of the pancreatic beta cells leading to an absolute insulin deficiency and in turn hyperglycemia. Now when I say autoimmune destruction, mind it that I am referring to the type 1A, which is the autoimmune form, since there's another type which is the type 1B, which occurs in less than 10% of the population and for which no cause has been found yet, and the pathogenesis remains clearly idiopathic. It is a chronic, complex, multifactorial disease involving two main components. Under broad headings, the one is the genetic susceptibility and the other one being environmental factors, which also includes viruses, microbiome and the diet. I have given a flowchart over here, which we will come to later on, and let us first discuss the genetic susceptibility and the environmental factors which leads to type 1 diabetes. Next slide. Among the genetic factors, the most important one is the HLA locus, which is present on the short arm of the chromosome 6. And this is responsible to as much as 50% of the genetic susceptibility of type 1 diabetes mellitus. Mainly the people with the genotypes of HLA DR3, DR4 and DQ. There are other non-HLA locus which have been found to that have been implicated with an increased risk of type 1 diabetes, like the insulin gene on the chromosome 11 with variable number of tandem repeats in the promoter region, the CTLA4 gene and the PTPN22 gene on the chromosome 1p, which increases the T cell reactivity, and the polymorphism of these cells leads to an increased chance of developing type 1 DM. Interleukin 2 receptor alpha, which is responsible for the proliferation of the T regulatory cells, the downregulation of which leads to an increase in the chances of developing autoimmune diseases. The interferon induced with helicase C domain 1, which is the 6th gene to be strongly associated with autoimmunity. It is responsible for contributing to the innate immune response by releasing interferon gamma and inducing apoptosis of the virus infected cells. Now the deficiency in the immunoregulation which occurs in autoimmune diseases. It has been postulated that there is a defective central and peripheral mechanisms of immunoregulation. Like the deletion of the autoreactive T cells in the thymus is one of the mechanisms that has been proposed for the induction of tolerance to self-antigens. Diminished expression of insulin in the thymus due to the presence of class 1 VNTR alleles 5' to the insulin gene, which we have already discussed earlier. Another school of thought was that the ineffective antigen binding of the type 1 diabetes mellitus prone HLA locuses like the DQ and the DR that promote the islet cell autoimmunity, that leads to autoreactive T cells escaping the thymic destruction and then it passes into the circulation. The peripheral T regulatory cells, they are essential for the downregulation of the T cell responses to both foreign and the self antigens, which is the major cause of the autoimmunity. The defects in the peripheral T regulatory cells in type 1 diabetes affecting both the natural killer T cells as well as the CD4 plus and the CD25 plus suppressor T cells. Now moving on to the environmental factors. A major cause of this is the infection by viruses. Two mechanisms have been postulated by which viruses have been thought to have been majorly responsible for triggering agents of autoimmunity or as the primary injurious agents. Mainly the viruses like the mumps, rubella, CMV, Coxsackie B3, B4 and reovirus type 3. From among the mechanisms, one of them is the bystander damage caused by the viral infections. Viral infections will induce islet cell injury and inflammation, thus leading to the release of the beta cell antigens and activation of the autoreactive T cell. Another postulate is that the molecular mimicry. Viruses will produce proteins that will mimic the beta cell antigens, and therefore their occurs a cross-reactivity between the viral protein with the cell tissue, and this leads to autoimmune diseases. The dietary factors responsible are the early weaning of infants and consumption of the cow's milk, which has been found that less than 3 months of age, when children are introduced to cow's milk, they have an increased chances of developing type 1 diabetes. Dietary toxins like the nitrites and the N-nitroso compounds, which are mainly found in the processed meat products, they are also responsible. Processed foods, they have a higher amounts of glycation end products. Microbial composition of the foods and the gut microbiota, they have been also implicated as the factors. And vitamin D. The vitamin D, active form of vitamin D3, this has been shown to inhibit T cell proliferation, and therefore deficiency of vitamin D might have been thought to have been as a cause of autoimmunity. Now, let's go back to the previous slide where we had shown a flow chart of how all these factors are leading to an autoimmune disease. Here, the genetic and the environmental factors, they are responsible for the production of the autoantigens. Like I said, that the environmental factors includes the viruses. They will produce a molecular mimicry, and that leads to the production of the activation of the cytotoxic T cells, which will produce cytokines, and therefore this leads to the activation of the T helper cells. Cytokines are released. That leads to the insulitis, inflammation of the beta cells which occurs, resulting into the death of the beta cells, and apoptosis, leading to type 1 diabetes mellitus. So this was all the etiopathogenesis of type 1 diabetes mellitus. Thank you.